All right, so today I want to talk about the idea of software for one and ideas for all. And that's a grandiose title because I needed to disguise the fact that this is kind of a rant. And I realize if you know anything about me, you know that's totally out of character, but here we are. So when I was a kid, I basically wanted about two things in life, two very specific things. The first is that I wanted to send people into space. I grew up in South Florida. It was a dream of mine for my entire life to work at NASA and to get to send people into space. And this is actually a photo of me sitting in a replica Mercury capsule, plotting ways that I could send my parents into space. The other thing I wanted to do, like so many probably people around a young age who get into programming and computers, is I wanted to make a video game. It was this amazing desire. I mean, I grew up in the SNES era, and I grew up in this time, this like amazing time of all these sorts of innovative new games. And I played Chrono Trigger and Secret of Mana and these sorts of things. I wanted to make that. I wanted to be a part of that. And I was a pretty proactive kid. And I truly did want to try to achieve these things. But when I looked at it, I kind of decided that making a video game was probably within my grasp relative to sending people to space. So I pursued the video game first. And I had a family friend who happened to be a programmer. And I asked him, I was probably about 10 years old. And I said, what does it take? What do I got to do to make a video game? And they said, well, you should learn C++. And so I saved up my money. I saved all my lawn mowing money. And I scrounged together and I got this book, Beginning C++ Through Game Programming. And powered with this book, with Notepad, on Windows 98 and using a slow-ass dial-up connection and Alta Vista, I attempted to teach myself C++. And I think it took me about the first week, let's call it 2 weeks, just to figure out how to compile C++. And after that, it took me another several months to power through this book, but I eventually did. I was so determined. I got to the end of the book. I did everything, and I went through it, and I had learned some amount of C++ for the amount of C++ that it is possible to learn by any human being. And I realized when I looked at it that the sum total of games I had created was 0, because a game to me didn't mean making, IO put stuff into the terminal. It meant moving sprites around on the screen. I meant doing interactive things and telling stories and having these sorts of experiences. That's what making a game was to me. And so I was not going to be deterred. I was going to figure out how to do this. So I spent a lot of time looking around and trying to find other options. And I eventually stumbled upon what I consider to be one of the greatest pieces of software that has literally ever been written, RPG Maker. It is impossible to overstate how important RPG Maker was to me. It is a formative youth experience. It's up there with Blender in terms of things that I've spent uncountable amounts of time in that changed the way that I interact with computers for forever. And it was amazing. If you're not familiar with it, you had a canvas that you could draw and you could build maps, and you had this set of sprites, and you could download other sprites, and you could download character sheets, and you could drag and drop them, and you could create whole worlds, and it had a combat system in it, and you had global flags you could trigger, and all these ways to interact. And it allowed you to tell all these interesting stories. It allowed you to build whatever you wanted to build. I mean, and I went deep. I played with this thing I went so deep into it for months and months and months. I mean, my game had a day-night cycle in it. And at night, different monsters would come out and other secrets to other clues would appear. And at the end of it, I made a game, and I was able to make it and share it with friends and allow other people to experience it. And I was so proud of it. I was so, so proud of it. And I finally got back to our family friend, and I said, look what I made. I made a game. And he's like, oh, cool. What'd you make this with? I said, RPG Maker. He's like, that's really cool. Now you should learn how to program C++ so you can make a real game. And I was crushed. I mean, I was already insecure. Let's be clear. I was a nerd. And didn't have a lot of self-confidence. But having someone tell me like, oh, this actually isn't real. This isn't really how you're supposed to do it. I'm not kidding when I say it drove me away from programming for the next decade. I just put programming behind me and I was like, you know what? This isn't for me. I'm going to go send people to space because that seems easier at this point. When I got back to programming eventually, I've discovered that things didn't change a whole lot. We still sort of do this to each other. And I think that person gave me what they believe to be really well-meaning, really good, constructive advice. Like, I think they truly thought that. And they thought that because they're looking at the industry and they're looking at what's accepted in the industry and what would it take to make a real game that like would go to market or something. And it's a trap that we all fall into. And we say there's a specific phrase that we use whenever we fall into it. And it's this idea of choosing the right tool for the job. I think a lot of us believe that the tools for the job are this actual toolbox where there's specific wrenches and pliers and, you know, Torx head screwdrivers and custom things. And when you need to solve a specific problem, you can go grab the exact one of those and solve your problem with it. But I just actually don't buy this at all. I actually don't think this is a compelling argument. I don't think there's any validity in this. Because at the end of the day, like, our favorite tools are like chainsaws, man. Like, they all do like a specific thing and they're really, really good at like that specific thing. But, you know, you can kind of use them for a lot. Like, if you really, you know, the old saw is like, if all you have is a hammer, everything looks like a nail. Turns out, if all you have is a chainsaw, you can use it to hammer stuff. Like, everybody can work with what they have. And yes, that includes all of your favorite tools. They're all things that we've got innate knowledge of, that our teams have come together and learned about, and we've invested time in. And you can, at the end of the day, you can make anything scale. If you give me a big enough engine, I'll make my house fly. Like, you can really make all of it work. It just comes down to how much time do you want to invest in it? How much energy are you willing to put into it? How much do you enjoy it? How much like life-bringing energy is it giving back to you? And even if we accept for a second that this was true, that there is a sort of so-called right tool for the job, well, then I guess the outcome of that, just looking at the industry broadly, is that there's really only three types of problems. They're the ones that JavaScript can solve, the one that Java can solve, and the one that Go can solve. I guess nowadays it's probably the one that you can write something in C++ and then rewrite it into Rust can solve. So, you know, I guess we've just all tacitly agreed that there's only three problems, or there's only three shapes of problems, and you have to pick one of these right tools. And this just doesn't make any sense, right? Because if we actually step back and look at it, it's like the things that people use JavaScript for, or Java or Go, are those actually the right tool for the right job? Is that actually the best way to go about solving it? Or are there other factors at work here? And so I just think this whole notion, the whole idea that you can pick a problem and then pick a tool to match it, it's just a myth. It doesn't exist. It's not a real thing. At the end of the day, the right tool for the job is the tool that allows you to think a specific way about a problem, that changes the way that you approach the problem. And more importantly, for those of us working in industry, it changes the way our teams think about the problem. What is our team comfortable working with? What is our team capable of dealing with? What can we all together get excited about maintaining? Because you're going to have to maintain it at the end of the day. The good news is, for those of us in this call, you've already decided that this doesn't make any sense. Because if it was true, well, guess what? We're all tacitly wrong. We're all the weird ones over here doing something no one else is doing, relatively speaking. And that's awesome, because we're not mainstream. That's a huge benefit to us. That's an incredible thing. And it's one of the things that keeps me around here. Not because I don't ever want to be mainstream, because we're not yet. It also means that we don't have, because we're not mainstream, we don't have to play by their rules. We don't have to compete with them on the things that they care about. And in fact, it's smarter to not care about the things that mainstream companies care about, because, at least for your own self, because at the end of the day, you can't compete with mainstream languages by trying to be more mainstream than them, because guess what? They're already mainstream. They already won tacitly. So trying to play their game is a losing proposition. So I've been thinking about this idea a lot, and I get asked the question a lot of, how do we make Elixir, when is Phoenix going to take over Rails? When is Elixir and the Beam going to become mainstream? What is it going to take, right? And I've been thinking about those ideas for my own self and the kinds of things that the kinds of problems I want to solve, and the kinds of solutions I want to start to examine. And for me, I think it comes down to the idea that we will win, we'll become mainstream by doing something no one else is doing, and by doing it better than anybody else could do it, and by leaning into the strengths that we have in this ecosystem. So the question then becomes, how do you actually go about doing that? How do you start to solve those kinds of problems? And what does that actually look like? So these are the rules for me. These are what I do on a daily basis. They're going to be different for you. Not everybody's going to have the same the feelings about this or want to do the same process. But this is how it works for me. The first step, and this is a very key step, is you need to become incredibly frustrated with the status quo. You need to challenge all of the preconceived notions about the status quo and get incredibly frustrated with the conventional solutions for things. You need to be really critical of the tools that you love. There are tools that I love using, including Elixir. I love writing Elixir. I'm also, in my head, incredibly critical of Elixir because it helps me think through what it would take for it to be better. And I think this is really important. I think that doesn't give you, that doesn't mean be a jerk. Doesn't mean go to somebody's open source repo and demand they change things or tell them they're doing it wrong or write some screed on some Medium or something like that. That's not the thing. What I mean though is you need to be critical of solutions and really think through the trade-offs that they were making and think through if you are comfortable with those trade-offs. After you've become incredibly frustrated enough to want to solve the problem, you need to get a hammock and you need to think a lot. This is an incredibly key step. And I do actually mean get a hammock. If you don't own a hammock, you should totally get a hammock. Hammocks are awesome. And I spend a lot of time in mine literally thinking about the problem and thinking about how I would go about solving it and the layers of the problem and how do I pull those layers apart and what's the actual root thing, not the aesthetics of the thing, not the symptoms of the problem, the root of the problem. How do I get down into that and start to think about different solutions and start to really try to get to the heart of the problem? Once you've thought about that, you need to go away and you need to try some stuff. And not all of it's going to work. And you need to be willing to try it. And it's probably going to fail. It's probably not going to actually solve the problem. It's probably going to be wrong. And you need to go back to the hammock and think through it more. This is also where you need to start reading papers. Start looking at research. Start looking at other languages. What do other people in other runtimes do? What do other libraries do? Go to the weird esoteric stuff that no one uses. If you've never written Eiffel before, go write Eiffel, because Eiffel will change the way you think about verification. If you've never written Haskell before, write Haskell, because it'll change the way that you think about composition. Go and experience other stuff and try a lot of things. And then finally, and this for me is an incredibly key, crucial part of this step, you need to share it with other people. Sharing it is scary. And it's often that we keep this stuff to ourselves because we're nervous about putting it out there in the world. If your repo, the thing that you're trying out, I don't know, you don't want people to make fun of it or to open issues on it, or, maybe it doesn't have tests or it's not formatted right or whatever. There's some reason you may not want people to see it yet. I don't know. I think the cost of sharing it with people is actually really low. And it's important because sharing it is how we move our ecosystem forward. It's how we as a community collectively will start to get better. And sharing things early and often means that, yeah, you're getting feedback, which you may consider both a benefit or a curse, depending on what your goals are. But at the very least, it's a way to express ideas. And at the end of the day, this is the beauty of open source. Open source is a gift. It's a gift freely given with no strings attached, right? You get to look, and it's not the source code that's the gift. The code, the lines of code is a benefit. The fact that you could run it, like download it and run it, that's just a cherry on top. The actual gift is the fact that you get to, for a small moment, look at how somebody else thinks. And you get to have their way of thinking potentially change the way you think about solving the problem. You get to learn from their experiences by going in and reading someone else's code and by looking at how they thought about the problem. And I've done this for a number of libraries, things that I've built recently. That I'm kind of going to just talk through a little bit. So the first is this thing called norm. And norm is a system for specifying data and for function contracts. And what it allows you to do is just say, you might have, it allows you to define the shape of data. And it allows you to say things like, this thing is an integer, and the integer has to be between 0 and 255, because in this example, we're building a RGB to hex converter. And also hex has to be hex values, it has to start with an octothorpe, those sorts of things. And we can start to say this stuff. As a self-proclaimed dynamic typing apologist, people often think I don't like verification or that I'm like anti-verification. And that's just simply not true. In fact, I love doing property-based testing. I do property-based testing for the majority of my libraries at work. I've played a lot with like TLA Plus and Alloy. Like these are things that I'm like very interested in. And so when I was setting out to create norm, I wanted to build something that was actually sort of more powerful than a conventional type system. Like, Idris people can talk to me about it later, but I wanted to build something that would allow me to say things like, is this operation commutative? Can I do that? And I wanted to prove that there was actually ways to build more verification, to provide more constraints and contracts and more interesting verification in the language, in Elixir that we have today. And so that was the goal. That was the problem I saw, and that's what I set out to solve for myself. I also recently came up with, or helped with some friends, and based on work I'd done at work, I wrote this library called Vapor, and it allows you to do runtime configuration. And it provides a bunch of benefits over the top of what we would traditionally use, like runtime, EXS and those sorts of things for, because it allows you to do mappings between things. It provides that out of the box. It allows you to do, it ensures that all the variables are there. It doesn't let you start up in bad states. And for me, this was really important because all of the projects I've ever ran, I've been running Elixir in production for a while now. And in all those products, I've needed to solve these same problems. And at Bleacher Report, where I work, we have 30, 40 services that we need to maintain. And all of them have these similar problems. And I wanted to solve that for all of them. And so that's the problem that I set out to actually work through and solve. And it went through a bunch of iterations before I kind of got something that was close to right. The final thing I wanted to talk about was this library called Groot. And I'm betting nobody has even heard of this. But it's a distributed key value store for very ephemeral data. It makes no claims to store your data in any real way. It's based on hybrid logical clocks and last write when register CRDTs. And we use this at work now for things like feature flags, for things like being able to toggle on and off stuff. That can be highly available and can also go away. And it was an interesting problem, but again, it was based on problems that I saw that I wanted to like really step back and think through how to solve. In each of these cases, for every single one, I have gotten questions from people in our ecosystem that say, why did you do this? Why did you go about solving this problem? And that I can have a discussion with, but I've actually been confronted with other people who go so far as to say, you shouldn't have done this. And I've actually encountered people who are mad that I like built these things and put them out there into the world because they think it pollutes the ecosystem, or it somehow detracts from something the core team's doing, or it gets in the way and makes it harder for new people to understand the language, or whatever the reason is. And to that I say, deal with it. because we're not gonna innovate. We're not gonna change anything if we wait for someone else to go and try to solve the problem. And to be clear, I don't know that any of these ideas are good. And in fact, they probably aren't good in some cases. They're probably bad. Should you use them at work? Almost certainly no. I don't know. You have to make that choice for yourself. But I do know that if we take the approach of like, oh, well, this gets in the way of something else, and we don't allow for the opportunity to try new things and to build new things, we're never going to do anything different. Like if everybody had that mentality, we'd never build anything new. We'd never try or explore anything. And beyond anything, for me personally, man, doing what everyone else is doing is boring as hell. I don't want to do that. I don't want to just do status quo. I want to do something beyond that. I want to dream bigger than what the rest of the industry is doing, or than what the rest of your coworkers are doing, or what the rest of other teams in Elixir are doing. I want to do something really, really weird and different. And I think there's great examples of that already in the ecosystem. Like, I don't know, I go back to Nerves as the de facto example of doing something that no one expects you to do. I mean, no one expects in the hardware world, expects you to put an interpreted language with a VM on hardware and run it. And yet they did it, and they did it for themselves, and then they shared it with the world. And now it's like this amazing, huge project that has all this life and energy around it, simply because one person thought it should exist and did it, and then shared it with everyone else. And I just think that's so cool, because it completely flips the narrative of what's capable of being done. I mean, the stuff that the sort of Japanese contingent is doing and talking about is incredible. And I get so excited every time they talk about it, because like they're putting Elixir on FPGAs, and they're doing all this like, you know, hardware accelerated Elixir and Beam stuff. And it's like, that's awesome. That's so cool. That's so exciting. And then there's like even more bonks ideas. Like people are doing machine learning on the Beam. There's a group trying to get the Beam, a WASM compiler for the Beam to work. Like people are writing languages like Gleam. Like Gleam is incredible. The fact that it exists is incredible. And it exists purely because one person believed it should and then shared it with the world. And I have not written Gleam, but I'm really glad it exists in the world, because it means that this ecosystem is even more vibrant and even more interesting. And finally, there's people who think it's a good idea to drive web UIs with WebSockets. And it's working. People are so excited about it, and it's working for them. Like, no one else is trying to do that sort of stuff. And we're using the capabilities of our ecosystem to go for it. I think if we want the Beam to be mainstream, if we want to continue using this as part of our jobs, if we want other people to experience how awesome this ecosystem is, how great this tooling is, then it's really simple. We need to build cool stuff, and we need to share it with people. And finally, I just want to say, like, you don't need anyone's permission to do something awesome. All you need to care about is that you want it to exist in the world, and go do it. And so I hope that as you leave, as you go back to your jobs, that after all these great talks, that you're energized, that you're excited, and you're ready to do something amazing. Because I think that is within our grasp. It is not hyperbole to say, I truly think that we can change the industry. And I think it just comes down to us working towards that, trying things that no one's willing to try. And if we do that, we could change the world. So thank you.
So did Eiffel inspire Norm?
Eiffel was definitely one of the inspirations for Norm. Yeah, there's several inspirations for Norm. Eiffel's definitely amongst them.
It's interesting to hear that Eiffel is actually what got me into the whole Erlang ecosystem in the first place, and it's when it was being pushed for not being the right tool for it. It was being pushed for being the right tool for the job when I ended up being 3 times more efficient than Erlang. But I have to say, you were born in the wrong decade, because if you started to code, you were actually started coding on the Commodore VIC-20 in BASIC, and then it was really for games, and you did not have to deal with C++. Promise that.
Yeah, I mean, it's deeply ironic that my first actual programming job, I spent years writing C and C++, and it's important that I've never looked back after leaving it.
Yeah, no, I did spend quite a few nights in the lab in university, chasing pointer errors, and then realized, oh wow, what is this? A garbage collector? I don't need to allocate memory and deallocate it, and there's those segmentation faults, core dumps, other than in the VM, which which were still rare. So yeah, cool. Any other questions?
Manuel.
Yes.
Manuel Rubino asked if you ended up developing that game.
No, I did not. I've considered it multiple times, like actually investing in it and trying it, but it's just never made it back up the list. I feel like I did. I feel like I got my fill of it. And at the end of the day, like I made the game I wanted to make when I walked away from it, which was literally all I wanted.
The game of walking away. But you did learn C++ in the end.
Yeah. I mean, I sort of fell backwards into programming. I studied electrical engineering and did a lot of microcontroller programming. And so I was sort of forced to learn C just as like part of my, studies and stuff like that. And so I realized pretty early on that I liked programming a lot more than I liked electrical engineering. So I got out of electrical engineering and got into programming, but the only people who'd hire me were people doing C. This is really the only language I knew. So